I find a lot of interesting stuff on the internet. How I see math word problems. If you have 4 pencils and I have 7 apples, how many pancakes will fit on the roof? Purple, because aliens don't wear hats. You're like, that doesn't make any sense. Well, that's about how much sense a lot of math word problems make to many students, okay? And if you're one of those people that can really relate to that, it's okay. You don't need to drop the class. I can teach you how to make sense out of these math word problems. But the fact is there's a lot of math word problems in chemistry. And so we're going to need to work at it. There's 2 kinds of people, the people that get word problems and the people that don't. And it's just how your brain is wired. It's how you think. It's not reflective of your intelligence. Although, you know, it could give you a complex as you're going through elementary and junior high and stuff when you just don't get it, and it can make you feel really stupid. It doesn't mean that you're stupid, though, okay? It just means that your brain works in a different way, and these problems don't make sense to you, and probably you never had a teacher that helped you enough that you could actually see what was going on. So that's one of my goals, is to help those of you who struggle with word problems. So some ideas about how to solve these sorts of problems. It requires some critical thinking. The answer is not going to jump out and bite you, okay? You're going to have to think about this and work at it. It requires some critical thinking. There's no simple formula that we can apply to every problem. One of the problems with the education system until just very recently is they were very focused on teaching to the test, right? You had to take the tests and No Child Left Behind, and you learn how to do these specific things that are on the test. But they didn't have time to teach people how to think. And so then if you have something that wasn't on the test, you didn't learn that. And so the sad fact is that we can't just use those formulas that we learned, but we can learn some problem-solving strategies. Many of the problems that we run into in chemistry end up being unit conversion problems. And I'm going to teach you how to do unit conversions. And then there are other problems that do require the use of specific equations. So it falls into 2 basic groups. Ones that you can think of as unit conversion or dimensional analysis problems, and other ones that you're going to use an equation. So when we convert between units, the units act a lot like variables in algebra, okay? And there is algebra in Chem 3A. It's not real complicated algebra, but there's some algebra, and if you need help, please ask me, okay? Lots of people algebra does not sit well with them, but we can figure out enough to get through here. So the units act like any other algebraic quantity, those x's and y's and things. And we will find out that we can use those units to help us figure out whether we're supposed to multiply or divide or what we're supposed to do. And that's called dimensional analysis. And this is a really, really important thing, dimensional analysis. I learned this as a junior in high school in physics class. And I would say that's probably the most important thing I learned in all of high school, was how to manipulate the units. My physics teacher showed us that, you know, even if you forgot the equation, if you just put things together so the units work out, a lot of times you get the right answer. It's awesome. Part of using dimensional analysis is always write every number with its associated unit. If it's a number that has a unit, those 2 go together, and you have to write the unit every time you write the number. Yeah, it's a little tedious sometimes. But taking the class over again because you failed, that's really tedious, right? So write the units. Always include units. And don't let the units magically appear or disappear, okay? You can't say, well, it must work out somehow, and here's my answer with the units I expect it to have. No, you should be able to see, well, this was meters over meters, and they cancel out, and the meters went away. Or I had centimeters times centimeters, and now I have centimeters squared. There's no wishful unit canceling, okay? So usually what happens in a unit conversion problem is we're given a quantity with one unit and we're asked to convert to another unit. And this follows this, these calculations are going to take this form. Whatever the given unit is, we're going to multiply by a conversion factor that relates the desired unit to the given unit, and then we'll end up with the desired unit. Let's just have an example there, because that's just, examples are really, really important. Let's see. So 5 yards is how many feet? 15. Yes, that's right. So this is an easy problem, one that most people can do in their heads, because you have experience with yards and feet, and you know the relationship, and you recognize which one's bigger and whether you should multiply or divide by 3. So we'll use this as an example of showing how the units tell us what to do. So the given unit is yards, and so that's what we start with, 5 yards. And we're going to multiply by a conversion factor, and we're going to end up with feet, the desired unit. What we want to have happen is we want the yards to go away. To get the yards to go away, we have to divide by yards, because anything divided by itself is 1. And you multiply by 1, and it doesn't change anything. So if we divide by yards, the yards will cancel out, because they act like variables in algebra, like the x's and the y's. But then we have no unit, so we need to multiply by feet. So this tells us that we're multiplying by the unit that we're trying to get, and we're dividing by the unit that we're getting rid of. And so then the units cancel out. This is dimensional analysis. We are analyzing the dimensions. We're analyzing the units to figure out what math things we need to do. But we have to have some numbers in there. And the numbers will be how many feet is equal to how many yards? Well, we know that 1 yard equals 3 feet. What's on the top of that conversion factor has to equal what's on the bottom, because 3 feet is the same length as 1 yard, isn't it? 3 feet equals 1 yard. They are equal. We're dividing 3 feet by 1 yard. This is actually numerically equal to 1. And so when we multiply by 3 feet over 1 yard, we're not changing the length of it, we're just changing the unit. And so then we end up with 15 feet. Like, well, that was real tedious, or something I could do in my head. Well, yeah, but we learn the process, and then when we get later to converting grams of oxygen to grams of hydrogen, can you do that one in your head? I can't either. But the units will tell us what to do. Those conversion factors can be constructed from any 2 quantities known to be equivalent. And so this is a table from your textbook that you may want to refer to. I think some of this information is also on the inside back cover. So 1 kilometer equals 0.6214 miles. If you're converting between kilometers and miles, you're going to need something like that. So you may have to look it up in the table. It may also utilize the prefixes. So we need to know some of those prefixes, those ones I circled in red. So if we need the relationship between centimeters and meters, if we know what centi stands for, we can do this without having to look up anything. Centi stands for 10 to the minus 2. So 1 centimeter equals 10 to the minus 2 meters. So construct conversion factors relating feet and inches. So the conversion factor usually takes the form of a fraction. And we can put the feet on the top and the inches on the bottom, or the inches on the top and the feet on the bottom. What's the relationship between feet and inches? 1 foot is 12 inches. Could we say 1 inch is 12 feet? No. We can't swap the numbers. The 1 stays with the feet, and the 12 stays with the inches. What happens sometimes with units that you're not familiar with is you get real, I don't know, lazy, crazy, something happens, and the numbers just go all over the place, and then you end up getting the answers wrong. So over here, we can upside down it, but then it still is 1 foot and 12 inches. So let's think about it this way. 12 inches equals 1 foot. If I divide both sides by 1 foot, is that still an equality? Is it still equal? Yeah. Because mathematical equations are a lot like teeter-totters or seesaws. If it's balanced and you do something to one side and you do exactly the same thing to the other side, it's still balanced, it's still equal. So I took that equation, 12 inches is equal to 1 foot, and I divided both sides by 1 foot. What is 1 foot over 1 foot? 1. Because the feet cancel out and the ones cancel out, and that is numerically equal to 1. So if I multiply something by this factor or this factor, I'm not changing the sign of it, I'm just changing the unit. I'm just changing the name by which I'm calling it. So what 2 factors could we write for inches and centimeters? Do you know how many centimeters are in an inch? 2.54. So 2.54 centimeters is equal to 1 inch. So 2.54 centimeters per inch, or 1 inch per 2.54 centimeters. Any questions? When you're solving problems, always make sure that your units work out. And look at the magnitude of your answer and make sure that it makes sense. Because if I was converting, it's about 30 miles from my house to Fresno City College. If I was converting 30 miles to inches and I came up with 0.42 inches, is that a reasonable answer? No, because we understand that mile is a long unit, a big unit, and inch is a smaller unit. The number should get bigger, right? And so, not always, but many times if you look at the answer, you can identify whether it makes sense or not. And it'll probably show up on a later slide, but I'm going to write it here anyway. One way you can do that is with what I call the bigger, smaller rule. Bigger, smaller. So we figured out that 5 yards was equal to 15 feet. So I'm going to apply the bigger, smaller rule to this. Yard is the bigger unit. A yard is bigger than a foot. The bigger unit has the smaller number. The smaller unit has the bigger number. Because as the unit gets smaller, you need more of them to equal the same amount of whatever. So that can help you, because one of the most common problems is that students end up converting in the wrong direction. And so you'll make the number bigger when you should be making it smaller, and the bigger, smaller rule can help you. And then remember, like I showed you on the previous slide, that these conversion factors can be inverted. You can upside down them because they're equal to 1. And so if you upside down them, it's still 1 and it doesn't matter. So we need to have a plan. The examples I've given you so far have been, very simple. Some of the problems we'll have to do are a little more complicated, and it's not always obvious on how you can get from here to there. One analogy I use is it's a little bit like crossing a stream. If the stream is very narrow, you can just step across it in one step. But if it's wider, you may have to find a place where there's some stepping stones. And it may be possible to get across the creek in more than one way on the stepping stones. Or there might be only one way you could get across. But before you go into the river on the stepping stones, you would be wise to figure out what you're going to do. You don't want to step over here if there's nothing that you can step on afterwards, because you'll just have to go back to the bank and start over again. Another idea is, you guys have all at least heard of Dora the Explorer, right? I think you're of that mostly of that generation where if you didn't watch it, maybe some of your younger siblings did. My kids were finally past the Dora the Explorer stage. But Dora was always trying to get somewhere. And who did she call for help when she didn't know which way to go? The map, right? And the map would say, well, to get to the Snowy Mountains, first you have to cross the bridge, and then you have to go through the scary woods, and then you get to the Snowy Mountains. And then they would chant that, right? Bridge, forest, Snowy Mountains. And they'd say it several times, right? Okay. Doing these conversion problems, same idea. You have to figure out where you are, where you want to go, the unit that you need to go to, and then you have to figure out how to get there. That's your map. And once you get the map, all you have to do is follow it. So when we're doing unit conversions, the map focuses on the units. And so instead of a bridge in the scary forest, you're going to have, oh, I've got centimeters and inches and feet and miles, something like that. So we'll do some examples. This one's all kind of written out. I'll go through it sort of quickly. So if you're converting from inches to centimeters, your map is very simple. This is a narrow stream. You can just step over it. I'm starting at inches. I'm going to go to centimeters. And the conversion factor is this relationship between these two units. You have to know the relationship for each of these steps. If we're going the other way from centimeters to inches, it's the same relationship but upside down. So we identify where we're starting, where we're going, we figure out how to get there, and 3 students could have 3 different ways of getting there. There's more than one way to get from point A to point B. You have to use what is given or what you already know or can look up. Okay? If I just have my calculator and I don't have access to the internet and I'm trying to convert the distance between my house and Fresno City College from miles to inches, I can't use the conversion factor such and such inches equals 1 mile because I don't know what it is. I'll have to take a different path. I would have to go miles to feet, because I happen to be able to remember that one. 1 mile is 5,280 feet. 1 foot is 12 inches, and I would use those 2 steps to go in that on that path. It's helpful, especially when you're beginning to use a solution map, to actually write it out. So we've got our given, and then you're going to have your steps, the map, and then what you're trying to find. So hopefully we're going to get a real example here soon. Oh, there's more stuff. I just want to do a problem. Okay. General problem-solving strategies. Sort. Read the problem all the way through. And sort the information. Usually the numbers are going to be important. Pull the numbers out, write them down, figure out what they mean. Strategize, figure out where am I going, what's my plan. And then solving is just actually doing it. And then at the end, check your work. Look at it. Does it make sense? And if you've written out all your work and your answer doesn't make sense, then you can go back and see what little piece went wrong. Okay, now we've got something. Okay, these are very simple word problems, but there are words. Convert 56.0 centimeters to inches. So where am I starting? Centimeters. And where am I going? inches. Do we know the relationship between centimeters and inches, or could you look it up fairly quickly? Yes. So since we know the relationship between those, this is just going to be a one-step path. And so then it might be helpful to actually write down that relationship. 2.54 centimeters equals 1 inch. So this is my map. This tells me where I'm going. Now, to actually do the problem, I need to start with, I meant to box that. Here I've got a number in here. There's only one number in this problem, so that's going to be the one I start with, 56.0 centimeters. In your path, there will be at least one arrow, maybe more. Each arrow is one conversion factor. So I look at my path, there's one arrow, I need one conversion factor, and that will equal something. So here's my path. Centimeters to inches. That wouldn't make a Dora episode, it would be too short. But here it is, centimeters to inches. So in my equation here, on the top, I am just copying these units. Centimeters to inches. So I put inches here. The path that I wrote tells me what units to put in here. Centimeters to inches, centimeters to inches. Now, this is a unit that I want to go away. So centimeters, go away. I don't need you in my answer. The way we get him to go away is we divide by centimeters. So I'm going to put centimeters down here. Those guys will cross out, cancel out. So we get all the units in first, and then we look at numbers. The relationship, centimeters and inches. There's a 2.54 in front of centimeters. It needs to be in front of centimeters. You can't put it on the top just because you'd rather multiply than divide. You just can't do that. And 1 inch, so 1 inch. So then we get out the calculator, and we've got 56 times 1 divided by 2.54. And the calculator spits out all these numbers. 22.0472441. And what's the unit?
Inches.
Inches. It's the only unit I didn't cross off. Would that be the best way to represent our answer? Significant figures. How many significant figures in 56.0? I heard 2 and I heard 3. There's 3. There is a 0. The 0 is a trailing 0, but there's a decimal point, so the 0 counts as a significant figure. Now this guy, what about that guy? Well, the relationship between inches and centimeters is exact. It's a defined quantity. So the numbers in this conversion factor are exact. They have an infinite number of significant figures. So they're definitely going to be bigger than 3. So then 3 is going to limit our answer. Anything within the English system, like cups to pints, inches to feet, anything like that's going to be exact. Anything within the metric system will be exact. And there's just a few things that go in between. Centimeters and inches is one of them. So if I'm going to round this to 3 significant figures, I'll end up with 22.0 inches. I need that 0 because this tells the reader that I know this with uncertainty in the tenths of an inch. If I leave the 0 out, then people are going to think I've estimated that to the nearest inch. So I don't want to do that. Any questions about that one? This unit conversion thing is a big deal. Significant figures, kind of a big deal. Dimensional analysis, huge deal. Okay? So let's get it all figured out now. So convert 5,678 meters to kilometers. What unit am I given? It's the one with the number, meters, right? And what are they asking me to find? Kilometers. When we're doing conversions with metric units, see how many prefixes we have. Here's one prefix. This one has a prefix. This one doesn't. One prefix, we can do it in one step. If we have two prefixes, we'll do it in 2 steps. But we have one prefix that tells us we can do it in 1 step. Because what we do is we go meter equals meter. That's true, right? A meter is equal to a meter. So on one side, I'm going to put a prefix, kilo, and on the other side, I'm going to put what the prefix means. Means 10 to the third. Why? Because I said so. You memorize it, that's it. There's no really understanding that or anything. But there, I made a conversion factor just because I know what one of the prefixes means. So here's our very simple path, meters to kilometers. So I start here with the number that I was given, 5,678 meters times. In the numerator is the path, meters to kilometers, meters to kilometers. What goes down here is the previous unit. I want to divide by this so they will cancel out. And sometimes we'll have multiple things all strung together. I want to divide by meters. A meter divided by meter is 1, goes away. Poof. It's too bad you can't make Legos go away like that. Then we need a relationship here. We wrote it out over here. Kilo means 10 to the third. A kilometer is 10 to the third meters. So kilo is on top, 10 to the third is on the bottom. Now you might say, well, I'd rather write it as 1,000. That's fine. You can do that. Now you do this on your calculator, and you may run into a question. Well, how do I put 10 to the third into my calculator? Well, is 10 to the third the same as 1 times 10 to the third? Yes, right? Because if you multiply something by 1, it doesn't change. So 10 to the third and 1 times 10 to the third, exactly the same thing. Does that look like scientific notation? Yeah, it does. Did I forget to tell you how to do scientific notation on your calculator? Yes, I did. Because it didn't get in the slides the first time I taught this class, and every semester I come to this point and I'm like, oh shoot, I need to add a slide, and then the thought goes away and I never do it. So we need to learn how to do that. There's this really cool button on your calculator. EE. Or you may have a calculator that says EXP. That stands for times 10 to the. So when you press EE on your calculator, you say times 10 to the. So to enter this number, let's go with a different color here. Oh, not that guy, this color. So to enter this into your calculator, you go 1 EE 3. So you go 5, 6, 7, 8, which reminds me of why was 6 afraid of 7? Because 7, 8, 9. Sorry. Fresh meat. Okay, 5,678 divided by 1 EE 3, which is 1,000. And that gives you a result of 5.678. And the unit is the only one left standing, is kilometers. This is a metric conversion, which means it has exact numbers. It will not affect the number of significant figures. We started with 4 sig figs. we end up with 4 sig figs. Any questions?